When the body is allowed to accelerate freely, there are two things we need to take note in this statement. The first one there is that the body is accelerating, but the body is allowed to accelerate freely. Acceleration implies the change in velocity with respect to time. That is, your velocity is changing. But when we say free acceleration, freely accelerating, that implies that we have subjected this body into a system, and the system is the one responsible for the change in velocity of the body. In most cases, this change in velocity is done uniformly, which implies that the free acceleration the body is experiencing is a uniform acceleration based on what the system is doing to it. Now, since as long as that system is in place, that implies that that system will continually supply the acceleration to the body. But one would think that since acceleration is change in velocity, increase in velocity, you would think that the body will continuously increase the velocity forever. Now, if this happens, there are so many things that will go wrong. And in fact, our universe could not have been able to operate under this kind of condition. And that's why there's a concept called terminal velocity. So if a body is accelerating freely in a system, in this situation, a uniform acceleration, the body is changing the velocity, increasing the velocity over time. At a particular point in time, the body will no longer be able to increase the velocity again. It reaches a velocity that can no longer be added onto. And this velocity is known as the terminal velocity. No matter what change that you have been experiencing from the beginning, you reach that terminal velocity and you begin to have a straight line velocity. That is, you now maintain that terminal velocity at a constant rate. And this happens in a system like a system of gravity if an object is released from the top of a very, very tall building or from a plane. And this object, ignoring air resistance, the object is falling down and falling down. The object will continuously increase their velocity uniformly based on acceleration due to gravity. But at a particular point in time, this object will no longer be able to increase their velocity again. At that point, they have reached what we call terminal velocity, and they will not be able to increase their velocity further. They maintain that velocity until they finally hit a barrier and they stop. This does not only take place in under the influence of gravity. It also happens in fluid. When you throw an object in the fluid, it increases its speed to a point whereby it can no longer increase the speed inside that object again. Then you see you have reached a point of terminal velocity, where all the upward forces have balanced the downward forces. And in this case, it seemed like the acceleration disappeared. Because once you have uniform velocity, the basic implication of that is that acceleration becomes zero. So where is our acceleration? That's my question to you. If you know where our acceleration is, put it in the comment section. I'll see you in the next one.